Geometry students to a new unit. We are now on Unit 2, which is angle reviews and angle terminology. So, if you're watching this, then hopefully you got most of what I talked about during the lecture. But this is the knowledge dump. This is the vocabulary dump. I always like to get all the vocabulary out there first in order to hopefully sink in over time. That way, when you actually get to the concepts that utilize the vocabulary, they aren't going to be as complex. So I fully expect that even though I'm going to go slowly with this, there's going to be a lot of rewinding and re-listening until the terms get into our heads. We've got 3 weeks, so I'm not worried at all about how well we're going to do. I know you all are going to do great. So the first things first, let's talk about terminology. I have assignment 2.0, which should be on your Canvas computer also. And so I'm going to go through and I'm going to give answers or possible answers to each of the terms as we go. And using this diagram, I'm going to offer a bit more of a detailed explanation of what we're talking about. So to start out, I don't know why I put this one first, a supplementary angle are angles whose sum add up to 180. That's going to be the 180 and 90 are going to be the two magic numbers that you need burned in your mind moving forward. Because we've got two parallel lines, as indicated by the little chevrons here. We've got one transversal, that is going to be line DJ, and then we've got another transversal, which is line CL. The transversals are basically lines that cut across parallel lines. But because the lines are parallel, the angles that the transversals generate have a lot of really, really unique characteristics. So in this case, supplementary angles whose sums add up to 180. Two angles are going to be angles ABD and angles JGH, excuse me. So I've got angle ABD, which is this angle right here, and which is this one right here, and I've got angle JGH, which is this angle right here. Now, how do I know that they're going to add up to 180? Years of extra geometry knowledge, we'll start out with that. But basically, I know that because the way that geometry works, if you have a transversal that cuts across two parallel lines and one of the angles generated is 90 degrees, all the other angles around it are going to be 90 degrees. And so I know that if I'm looking at angle ABD, and that's what I'm looking at here, ABD, and I'm assuming that when I call out a line, you understand what line I'm looking at. But I've got angle ABD here, that's going to equal 90 degrees. Because this side here is 90 degrees. So that means the traversal is cutting the two parallel lines at 90 degrees. Every angle generated by that traversal is going to be 90 degrees around the intersection. So, supplemental angles. It is important to remember this. Supplemental angles do not have to be next to one another. What they are angles where once you add them up, they equal 180. And that's all they need to do. It doesn't matter if they're next to each other, it doesn't matter if they're all the way across on the other side of the drawing, it doesn't matter. As long as they add up to 180, that is a supplementary angle. Alrighty. Complementary angles. Those are not angles that tell you everything that you want to hear. Those are angles that when they add up to 90 degrees. So much like you know what, let me throw up an example here. So that's going to be angle ABC and angle CBD. And just for quick angle notation, when I draw a single line, that means that I'm assuming that it's one measure. If I'm drawing two lines, that means that it's a different measurement. I'm highlighting what the angles are, but I'm showing that they aren't equal to one another. If I used one line here and then one line here, I'd be saying that angle ABC equaled angle CBD, but I don't know that. So that's why I use the two. So I have one half circle here and then 2 half circles. That indicates that they are 2 different measurements. All right, so angles whose sum adds up to 90 degrees. I chose these 2. They're right next to each other, but they don't have to be. Just like with the supplementary angles, as long as the 2 angles add up to 90 degrees, they're considered complementary. And so it just so happens that these are right next to each other. So if I take the angle measurement of ABC, and I take the angle measurement of CBD, that adds up to 90 degrees. As we mentioned earlier, you have 2 parallel lines and a transversal cutting across the 2 parallel lines. So in this case, I'm just looking at line DJ. If it cuts across at 90 degrees, then every other angle that's generated by the intersection is going to be 90 degrees. So however angle ABD is going to be bisected or partitioned, I suppose I should say, I know that however it's partitioned, ABD is going to equal 90 degrees. And so complementary angles, ABC and CBD, are going to add up to 90 degrees as well. Alrighty. I have a feeling this is going to get a lot messier as we go, but here we go. Vertical angles. Now, vertical angles are opposite angles that are formed when 2 lines intersect and they only share a vertex. So, in general, you have 2 lines that are intersecting one another, and they're intersecting at a point. 2 lines intersect at a single point. So you have 2 lines intersecting at a single point. Vertical angles are angles that are generated that share the vertex, but not any sides. So, these angles here. And one of the things that you learn, one of the things that we know, is that the vertical angles are equal to one another. That's not a smiley face. That's me showing that this angle is equal to this angle, and this angle is equal to this angle. So where are some vertical lines? So where are some vertical line segments on this drawing? I'm looking at a good one right now. I'm looking at a couple of good ones. I'm going to say line segment KHL, and the vertical line and the vertical angle that shares a vertex but no sides is going to be BHG. So those would be examples of vertical lines. By the same token, this would be a vertical line for this. So all you're looking at is 2 lines. In order to look at a vertical line, you are just looking at 2 lines and an intersection. There may be more lines going through that intersection, there may be more lines that are coming around there, but all you need to do is focus on the 2 lines that are forming the vertical angles. And you can see what the vertical angles are and how they're generated. All right. Next we have adjacent angles. These are angles that are next to each other. I mean, there's really not much to it. An adjacent angle, it doesn't have to be a complementary angle. It doesn't have to be a supplementary angle. It doesn't have to have anything to do with any numbers, with any addition. It doesn't have to do with anything. All they are just angles that are physically next to one another. So DBE, an adjacent angle to that would be EBH. So DBE is this one up here, so D down to B, all the way out to E. So it's this angle with the box on it. An adjacent angle is going to be EB down to H. So it's just going to be this space here. So this angle here and this angle here are just adjacent angles. And that's it. I mean, they're just angles that are directly next to one another, and they don't have any real special relationship aside from that. But you just need to know that it's an adjacent angles next to each other. Now, linear pairs, mentioned earlier with supplementary angles. Supplementary angles are angles that when you add them together form 180 degrees. Linear pairs are angles that are right next to each other. So linear pairs are an adjacent angles who add up to 180, and you can only have 2. You can add up, and so you can only have 2. Generally, that's all you need. So what would be a good example of a linear pair? All right, I can see a pair. So I've got ABC, so that's one angle. But now what I'm going to do is I'm going to say CBE. So I'm going to say these are linear pairs. So ABC, CBE are linear pairs. Why do I know that? Because ABC is this angle here. So if I want to take that angle and add an angle to it that forms a straight line, then I need to find the angle that I can add to it so that AE becomes a straight line. So in this case, I'm going to say CBE. This whole big angle here plus this little tiny angle here equals a straight line. Because those two angles are right next to each other, they form a linear pair. An important distinction to make: supplementary angles can be anywhere. Linear pairs have to be next to one another. So all linear pairs are supplemental angles, but not all supplemental angles are linear pairs. So that's an important distinction to remember. Next is alternate interior angles. These are angles, reading the definition, that lie between two parallel lines and are on opposite ends of the transversal. So in this case, I'm going to say angles ABG, which is going to be this one here, and BGH, which is going to be this one here. So what I'm looking at as far as again, a lot of these terms are terms relative to the parallel lines and the transversal you're working with. You must have two parallel lines in order for any of these definitions to matter. Then you have to have one transversal that's crossing them. So as soon as you define what the parallel lines are that you're looking at and the transversal that you're focusing on, now you can start using some of these terminologies, because there is no one answer. It's all relative to what you're looking at. It's kind of like with the constructions. There is no one correct construction with the prompts that you're given. With this one, there are specifically correct answers, but it's all relative to the things that you're looking at. So in this case, I've got two parallel lines. So these are the only two parallel lines I have, so that makes it easier, but I've got two transversals. So the transversal I'm choosing to focus on and I'm choosing to look at is the transversal DJ. And so I'm pretending that CL doesn't exist at all for the purpose of this label. So alternate interior angles. You have a transversal cutting across two parallel lines. Alternate interior angles are this one here and this one down here. They're internal angles, but they're not on the same side of the transversals. Exterior angles are on the outside of the parallel lines. Interior are here and here, are inside the parallel lines. But again, relative to the transversal. If I were to go to, okay, let me get this cleaned up here. If I wanted to take these two parallel lines and I wanted to look at CL as the transversal, so I'm completely ignoring DJ. Taking these two and I'm looking at CL. The alternate interior lines that I'm looking at, I would pick the first interior line to be EBH. So I'd be looking at this one here. And I'm just choosing EBH. It's completely arbitrary which one you want to look at. But the only alternate interior angle to this is going to be HGB, so this one. So again, I've got the parallels, I've got the transversals. The interior lines are the ones inside between the parallels. It's in the space between the parallels. And if it's on this side of the transversal and it's alternate, it's going to be on the other side of the transversal, but still inside the parallel lines. So alternate interior angles. Now those of you literary minds, or those English majors among you that say, well, you have alternate interior angles, do you have alternate exterior angles? Why, yes, I do. With alternate exterior angles, all you're doing is you're looking at, trying to see which one's cleaner to do this with. Well, I'll start with the basic. Start with the basic one. Alternate exterior angles is the exact same way. So you have an alternate angle. So you're looking at the first exterior angle. So I'm going to look at this one. So I've got my parallel lines. I've got my transversal cutting across the parallel lines. If I'm looking at this as my first alternate exterior angle, then this is the other one. The alternate exterior angles are always a pair. It's always a pair of them relative to a single transversal. Now, some of these identities are going to get pretty complicated, but you can use their definitions to solve for what these vocabulary words are. But again, relative to what you're looking at and relative to what you start with, there are a couple of different answers. I chose this line here and its alternate exterior angle, the alternate exterior angle to it is this one down here, because I've got the parallel lines, I've got the transversal. They're exterior because they're outside of the parallel lines, and they're alternate because for this one I'm up here, I'm choosing the same one down there. So going with the examples that we have right here, I will go with ABD, which is this one here. So I'm looking at the two parallel lines, and I'm choosing to look at the perpendicular bisector here. So with ABD, the alternate exterior one, oh, there we go, is going to be JGH, so it's going to be this one. So again, alternate exterior. Exterior means outside the parallel planes, so outside the parallel lines, so here. Alternate means that it's on the other side, of the transversal. So outside, other side of the transversal from this side, alternate exterior angles. All right. Corresponding angles are pairs of angles that are on the same side of the transversal that occupy matching positions relative to the two lines. So again, if you have a transversal, you cannot have a transversal unless you have two parallel lines, at least two. So this isn't a transversal. It's just two lines intersecting, who cares? This is a transversal because I've got these two parallel lines. Now it's a transversal. And because it's a transversal crossing these parallel lines, now we have these angle measurements. Now we have these angle definitions. Now we have these angle relationships that we can just assume all these different characteristics from in order to solve problems. So corresponding angles, according to our big one here, is just going to be angles ABG, so this one, and FGJ, so it's going to be this one. So looking at the transversal DJ and the two parallel lines. Corresponding angles means that if you pick an angle on one parallel line relative to the transversal, that the corresponding angle is just going to be the same spot, the same relative position. So like if you're looking at this as a compass rose, we have north-south with the DJ, we have east-west with AE. If the corresponding angle I'm working with is southwest, then that means that the corresponding angle I'm working with down here is also southwest. And that's all that means, is it's the same angle on the other parallel line relative to a transversal. Okay, consecutive interior angles. These are pairs of angles that lie between two parallel lines on the same side as the transversal. So, just using our general diagram here, we talked about alternate interior angles, where you had one on one side of the transversal, and then if it was an alternate interior angle, that was on the other side of the transversal. And it was interior because it was between the two parallel lines. So these are consecutive interior angles. So it's just going to be, let's see, what do I have written down? So angles DBE, that doesn't make any sense. Yep, so consecutive interior angles, they're pairs of angles that lie between two parallel lines on the same side of the transversal. So in this case, I'm going to pick GBE, so I'm going to pick this angle here. So again, the transversals I'm working with, that I'm choosing to work with, are the two parallel lines and DJ. Those are the only three things I'm looking at. When I'm defining these lines and these line relationships, it's the only one I'm looking at. Does CL cut through this angle? Yes, but I don't care, because the angle I'm looking at is GBE, and its consecutive interior partner is going to be BGH. Now I should have gone over the naming of angles, and so me picking this angle where it is, and where so I shouldn't be going over new material here, but consecutive interior angles are going to be, you have an angle that's on the inside, so you're looking at the transversal, there we go. You're looking at the transversal. Consecutive interior angles means relative to the transversal, you go one interior angle, and the consecutive interior angle is right next to it. And so you're looking on the same side as the transversal. It's not alternate interior, it's consecutive interior. So it's going to be on the same side of this transversal inside your parallel lines. So we're looking at, for a more simplified diagram, looking at this one and this one. Consecutive interior angles. So for this last definition, consecutive exterior angles. Well, if I use a simplified diagram, consecutive exterior angles, they're going to be on the same side of the traversal relative to the parallel lines. So if I pick, I'll just pick this one just to be wild. So I've got my two parallel lines, and I've got my transversal. The consecutive exterior line means that it's the next exterior angle relative to the parallel lines, but that has to be on the same side as the transversal. So if I pick this angle, it's got to be on this side, but it has to be outside the parallel line, so it's going to be this one. So an example that I have here would be angles ABC. So I've got this angle here. And because I'm using ABC, now the transversal I'm focusing on is going to be CL. So I've got my two parallel lines again, but the transversal I'm concentrating on is CL. Like I said, this seems like I'm beating a dead horse with the same thing over and over again, but you're going to get some pretty busy drawings, and it's important that you be able to define what it is you're looking at and what angles share which properties here. So I've got ABC, and then the consecutive exterior angle is going to be GHL. Now you'll notice that these don't really have a lot in common with one another, but that's incidental. The fact is that this is the relationship that they have. They are consecutive external angles. Consecutive as in they are the same side of the traversal. They're exterior, so they're outside the parallel lines. They're outside the space generated by the parallel lines. So that's a good introduction to some of the angle-based terminology. Again, you have to start out with two parallel lines. Once you have two parallel lines, you have to have a transversal. You have to have a line that cuts across those two parallel lines. Once you have that transversal, and I have two up here because I wanted to demonstrate complementary angles. But once you have that single transversal, all of these different angles have all of these different relationships and all of these different terminologies. But once you pick an angle, there's usually only one answer. There's always going to be one answer relative to that one angle for what you're looking for. Whether it's alternative interior, alternative exterior, consecutive interior, what have you. Once you start looking at an angle, then you have to figure out what its made is relative to those definitions. and the easiest way to get through the definitions is just to do the worksheets and get through them. So this has been assignment 2.0, worksheet 2.0. Let's move on to 2.1.